Hello guys, welcome back to my channel Algorithm Avenue. In this video, we'll be discussing one interesting concept called memoization. Okay, why I'm actually calling it as interesting is in this video we'll be combining computer science and machine learning concept together and we'll be working on it. Okay, now let us see what is actually memoization. Now to understand what actually is memoization is we need to first understand what is the purpose of introducing this concept. Okay, now to understand why this concept is actually introduced, let us see a code example.
Now, in this section of the video, we'll be seeing why actually this memoization concept has been introduced with the help of small code example. I'm choosing Fibonacci series as my example. Now, let me code for Fibonacci series. Import time module, and this is the Fibonacci series function. If n equal to 1 or n equal to 0, I will be returning 1 or just a second. Yes, I'll be returning 1, else I'll be returning fib of n minus 1 plus fib of n minus 2. Okay, this is the basic function recursion in Fibonacci series, right? Now let me run this. Okay, now start is equal to means I'm measuring the time taken by this function for calculation of each numerical value. Okay, for that I'm storing that in start is equal to time. Let me calculate first for Fibonacci of 10 and print time minus start. Okay, now let me run this. You see that for calculating the numerical value 10, for determining the Fibonacci series of 10, it is taking something around this seconds. Now let me calculate it for some larger numerical value. Let's say it's 49. Let me run this. Now you see that for a smaller numerical value, it has immediately given me some value, right? But in calculation of the larger numerical values, you see that how much time it is taking. It's around 13 seconds. It's crossed around 13 seconds. Means if you are taking still larger numerics like 100, 200, 300, it may take more time for the calculation of the Fibonacci series. That is basic Fibonacci series. So to overcome this problem, the concept of memoization has been introduced. Okay, now in the next section of the video, we'll be seeing how this memoization concept actually solves this problem.
You have seen the example of Fibonacci series where you are using Python functions to determine the Fibonacci series of a particular numerical value. Okay, now when you are determining the Fibonacci series of a smaller numerical value, the time complexity is being very much low. But when you are determining the value for larger numerics, the time complexity is being very much higher. Okay, now let us understand why actually this time complexity is being increased. Let us say we are calculating the Fibonacci series of 6. Okay, now to determine the Fibonacci of 6, first we need to determine Fibonacci of n minus 1, that is 6 minus 1, it's 5, and Fibonacci of n minus 2, that's 4. Right, now again Fibonacci of 5, 4, 3, 3, 2, 3, 2, 2, 1, 2, 1, 1, 0, again 2, 1, 1, 0, 1, 0, 1, 0. Okay, this is my last tree. 1, 0. Okay, now when you observe, you're just recalculating a lot of things over here. Now to determine the Fibonacci series, Fibonacci of 6, you're calculating for 5, you're calculating for 4, but here you're calculating for 4 and again recalculating for 4 over here. And here when you observe, here you are calculating for 3, again recalculating for 3 over here. Means to determine a Fibonacci series of a numerical value, you are doing lot of recalculations over here. So due to this recalculations, what's actually happening is the time complexity is being increased. So this is a smaller number, so it's not being very much affected. But when you take larger numerical values like 100, it will be highly affected with this time complexity. Okay, means for the calculation of the 100 Fibonacci series, the time complexity will be very much higher. So to decrease this time complexity, we have introduced the concept of memoization. Okay, how actually this memoization decreases the time complexity is it stores the values, it stores the output values for a particular input. Okay, now let us see an example. Now for the same tree, here you are calculating the Fibonacci of 4, and here again you are recalculating the Fibonacci of 4. But if you are able to store the Fibonacci of 4 over here, the same output can be used over here, right? And again, if you are able to store the Fibonacci of 3, you are able to reuse it again when again it reoccurs, right? Instead of again recalculating the things, you are able to reuse the things when it's actually necessary, right? So this is the entire concept of memoization. Okay, now let us implement a small code example on the Fibonacci series with this memoization concept.
In our previous section of the video, we have successfully discussed about the concept of memoization. Okay, now what we will be doing in this section of the video is we'll be implementing the concept of memoization in the Fibonacci series function. Okay, let's start. First, I'm importing the time module. Now I'm creating the Fibonacci series function def fib of n comma d. In the further part of the code, I'll be explaining you what actually the value of d is. If n in d, return t of n. If n less than 0, return 0. Okay, else calculate d of n is equal to fib of n minus 1 comma d plus fib of n minus 2 comma d. Then I'll be returning d of n. This is my Fibonacci series function with memoization concept implemented. Now let me calculate the time taken by this Fibonacci series function in determining for the larger numerical values. Start is equal to time, then d is equal to, now let me explain you what actually d is. D is nothing but a Python dictionary. D is nothing but Python dictionary which stores the values, which helps us to store the values. Now let's say I'll be storing 0 for n is equal to 0, I'll be storing it 1. For n is equal to 1, I'll be storing it as 1. Now next time when n is equal to 0 in my Fibonacci series function, what I'll be doing is I'll be fetching through this dictionary and I'll be taking the value of n is equal to 0 and I'll be using it in the function. Okay, similarly I'll be doing it for each and every numerical value. Now let me create the dictionary over here. 0 is 0, 1 is also sorry, for 1 it is 1, and for 0 it's also 1. This is my Python dictionary. Now I'll be calculating it for 100. Now let's say we are calculating it for 100 and I'm passing dictionary over here and I'll be printing my time taken. Now time minus start. Yes, you see that for fib of 100 where you have taken lot of time with in computing for the previous function, but whereas you have implemented the memoization in this function, it is taking around 0.00025 seconds. Means it is being time efficient. Means our memoization is helping to decrease the time complexity, but somehow little increases the space complexity. Okay, this is the entire concept of memoization, and this is the code example with the help of memoization concept implemented in the Fibonacci series function.
Yes, in our previous section of the video, we have successfully implemented the concept of memoization on our Fibonacci series program. Okay, now you may have a doubt that how this memoization concept is actually related to backpropagation algorithm. Now, let's relate our memoization concept to backpropagation algorithm as well. Okay, these are the two equations that I have taken from my backpropagation algorithm. Okay, this is one of my partial derivative and this is my other partial derivative. Now to determine this partial derivative, I am using these three terms, and to determine this partial derivative value, I am using these three terms. Now when you observe these two equations, you see that there are some common terms. Okay, this is one set of common term and this is another set of common terms. Okay, now let's say you are calculating the derivative value of dou L by dou W11. Okay, now when you are calculating this derivative value, you first determine this derivative value, you second determine this derivative value, and determine this derivative value. Okay, now again you come to second equation. Now when you come to second equation, you see that the same derivative value is being used over here. Okay, now what you can do over here is you store this derivative value in the internal memory. Okay, you store this derivative value in the internal memory and same as this derivative value. Okay, you store both of these derivative values in the internal memory, and again when they reappear in the derivative calculation, you use them from the internal memory. Okay, instead of again recalculating it, you use them from the memory, so due to which the time complexity will be completely reduced. Okay, this is how we use memoization concept in back propagation algorithm. Okay, but there is a twist here. The famous frameworks like PyTorch, TensorFlow doesn't actually implement this memoization concept in their internal implementation of back propagation algorithm. Now let us see why. Okay, generally in larger neural networks, we need to calculate lot of derivative values. In calculation of this lot of derivative values, you need to parallelly store them in the internal memory. Okay, now when you store this millions of derivative values in the internal memory, what happens? The memory usage will be increased. Okay, parallelly it's being less time complex, but the memory usage is being increased. Okay, means it is not being memory efficient. Our proposed method of memoization and backpropagation algorithm together is not being memory efficient, or the memory efficiency is increasing, means the memory usage is increasing. So that is why famous frameworks like PyTorch or TensorFlow doesn't internally implement memoization concept in the back propagation algorithm. Okay, you may also have a doubt that then why are we actually relating both these concepts? Okay, now you need to get an idea over here. When you are able to reduce this time complexity, okay, when you're sorry space complexity, when you're able to reduce the space complexity, it could be a wonderful research paper which implements the back propagation algorithm well. Okay, now when you are able to reduce the space complexity, you are reducing the time complexity parallelly. You are reducing the time complexity and parallelly you are reducing the space complexity as well. So this implements the back propagation algorithm more efficiently. Okay, so this could be a wonderful research paper, so I request you to work on this research. Okay, if you are able to, it's well and good. Okay, this is the entire concept of memoization with back propagation algorithm. Okay, thank you guys, hope you like this video. If you like the video, please like, share and subscribe. Thank you.